Hello and welcome to another video in geometry. This is section 2, and this is a video about perimeter and area of rhombi, trapezoids, and kites. Okay, and so what I want to do is we want to solve problems involving area of a rhombus, trapezoid, and kite. And then doing that in the coordinate plane, and then we want to be able to calculate the perimeter of those in the coordinate plane as well. So what I want to do real quick is just talk about the area formulas for rhombi, trapezoids, and kites. Let's first talk about trapezoids. So let's look at, let me zoom in further, make it smaller. So let's talk about trapezoids. Okay. And I just want to draw a generic trapezoid here. Okay. And I'm going to label this length here, this length from here to here as my first base. Okay, call it B sub 1. Over here, okay, I'm going to call that this top line here my second base, B sub 2. Okay, and then the last thing I want to do is come over here and draw in a line that is perpendicular from one base to the other. We're going to call that the height. Okay, so if I have that, then my area formula, area of this, is going to be the height over 2 times B sub 1 plus B sub 2, okay? Now I could also write it like this. I could also do it as height times B sub 1 plus B sub 2, and then all divided by 2, okay? It doesn't matter which one you do. But the main thing is that you have to add the two bases together and put that in a quantity and do that before you do anything else, okay? So that's it for trapezoids. Now for kites and rhombi, those two actually have the exact same formula. So kites, I'm going to do this. I'm going to do a kite slash a rhombus, rhombi, okay? And I'm going to just draw two generic, I'm going to draw a kite here real quick. Okay, here's a kite. Whoops. Okay, and then let me draw a rhombus. Okay. And it's not going to be perfect, but what I know about a kite is I know that these two parts are congruent, and these two parts are congruent. In a rhombus, I know that all four of these are congruent, but with the common piece is that their diagonals intersect at a right angle. So what I want to do is I'm going to call this diagonal 1. Okay, I'm going to kind of color code these a little bit, and then call that diagonal 2. All right, so let's do this. I'm going to call this diagonal, all right, from, my long diagonal here, I'm going to call this diagonal 1, okay? And then over here, my other diagonal, we'll call this diagonal 2, okay? And it doesn't matter which one you call which. We're going to be doing the same thing with them. We have the same formula, but I just want to make sure that we are able to understand which ones are the diagonals. So this is diagonal 1, and then this one is diagonal 2, okay? Now, our area formula here for these, area is equal to, and you can do it two different ways, diagonal 1 times diagonal 2, all divided by 2, okay? Or we could do this. We could say 1/2 times diagonal 1 times diagonal 2, okay? And that's it, all right? So that's what I have as far as my formulas, okay? And we'll need to know those. All right, so what I want to do, we have this, this trapezoid here, and it wants us to calculate the area of this trapezoid in the coordinate plane. So what I want to do is, I don't know what these specific lengths are. However, I do know the points of all these different vertices. And so what I'm able to do is I'm able to actually draw in, actually find these values. So the first thing I want to find is, let's find this length from Q to T, okay? And let's call this B sub 1, okay? So to find that, All right, let's draw in our right triangle here. All right. And then let's draw in a right triangle to find RS, which is B sub 2. Okay. And then let's do the same thing, but and this one's kind of hard because it's not, all these points are they're not all there. So you could do you could do the distance formula on this, but let's also find RU here real quick. Okay. So now what I want to do is kind of think about how I want to label these triangles. Okay. So from Q to T, okay, my horizontal distance goes from 1 to 19. Okay, and so the difference between 1 and 19 is a length of 18. Okay, and then this vertical distance here that I have goes from 5, okay, a y value of 5 to a y value of 8. So that length is 3. Okay, so that's a 3 by 18 triangle. Over here on this, from my height, okay, going from 6 to 7 on the x, okay, this distance here is 1. Okay, so that's a 1. And then the long length right here is going to go from 1 to 7, which is a length of 6. Okay, and then what I have from R to S, I have this vertical length here, which goes from 1 to 0, which is just going to be a length of 1. Okay, and then the length from 6 to 12, which you can kind of see here, is going to be a length of 6. Okay, so what I know is that RS is actually congruent to RU. All right, so because we have the same triangle, we have a 1 by 6 triangle. All right, so let's go ahead and let's take a look let's just do QT first. And QT is going to be the square root of, and let's do 18 squared plus 3 squared. Okay, so let's do the square root, let's do 18 squared, what's that? And that's going to give me 324 and then plus 9. Okay, so that's going to give me the square root of 333. Okay, and simplifying that, let's see what perfect squares go into 333. And so I know I could split this up into the square root of 9 times the square root of 37. Okay, and this would really simplify down to the value of 3 times the square root of 37. Okay, so we'll get a decimal approximation here in a bit. Okay, so we have that value. RS, let's do that one. Okay, RS is a 1 by 6 triangle. Okay, so if I come in here, we're going to get the square root of 1 squared plus 6 squared, which is going to give me the square root of 1 plus 36. So that's going to give us the square root of 37, which I cannot simplify. That's a prime number. Okay, and so then RU is the same thing. RU was a 1 by 6 triangle. So I want to do the square root of 1 squared plus 6 squared. Now, since I've already done this work, I don't need to do all this. I already automatically know that I'm going to get the square root of 37. Okay, so now I have all those values, okay, and so let's do this. I'm going to say that B sub 1, okay, I'm going to say that B sub 1 is equal to 3 times the square root of 37. Okay, I know that B sub 2 is equal to the square root of 37. Okay, and then I also know that my height is equal to the square root of 37. Okay, so in my area formula, okay, and let me write it up here. All right, my area is equal to the height times B sub 1 plus B sub 2, all divided by 2. Okay, so let's put those values in. So for the height, I'm going to put in the square root of 37 times 3 times the square root of 37. plus the square root of 37, okay, and then all divided by 2. Okay, so if I add these two values together, 3 times the square root of 37 plus the square root of 37, that's going to give me this. I'm going to get the square root of 37 times 4 square root of 37, okay, all divided by 2. Okay, now when I do the square root of 37 times the square root of 37, okay, it's going to give me, I don't know, something crazy. But when I add, the thing that hopefully we're seeing here is that when you multiply the square root times, itself, all right, you're going to get the square root of 37 squared, which is going to give you 37, okay? So I can rewrite this then as 4 times 37 over 2, okay? Now, if I take 4 divided by 2, that's just going to divide out to 2 over 1, okay? So therefore, I'm just going to get 2 times 37. And so if I take 37, multiply it by 2, that's going to give me 74. So the area of this is 74 units squared. And that's it. Okay. So kind of tedious. It is important that we're able to find these lengths and then plug them in and then operate with those lengths, okay? All right, so, one thing I can also do here is I can do the box method with a trapezoid as well, okay? So if I have this trapezoid and, one thing I would like to do is to draw a box around this so that we can just go ahead and so let's do this box here. And so connect all these dots and make triangles around that so that we can just find the area of the total rectangle and then subtract out the areas of these triangles, and we'll just go from there and find the area of this. Okay, so first things first, let me do this. I know that the length from here to here, okay, and I got to use my scale down here to help me with that. The distance from 8 to 18 is a length of 10. Okay, so the whole thing is 10. Okay, and then the total height that I have goes from 4 to 16. Okay, and I'm using these numbers over here, and that's going to be a total length of 12. Okay, so the area of the whole rectangle is going to be an area of 10 times 12. So this is 10 times 12, which is going to give me 120, and this is units squared. Okay, so that's the area of my big rectangle. Now let's go through and let's find the area of all my little rectangles, or I'm sorry, the little triangles. Okay, and I'm going to switch up my color to red so that we kind of have those different distances. Okay, and so this is going to be a length, okay, so from 4 to 12, from here to here, this length is going to be 8, okay, and then from 14 to 18, it's going to be 4. Okay, so I'm going to zoom in here. This is going to be a 4 by 8 triangle. Okay, if down here was a length of 4, okay, and that was 2 units long, then this is going to be a length of 4. Okay, so in this triangle, okay, this one's going to be 4, and this part's going to be 4. All right, I already know that this part over here, this length of this triangle is going to be 12. Okay, and then this one is going to be 6. Okay, so now that I have all those lengths, I'm going to transfer those numbers over here to, so I've got a 4 by 8, so triangle 1. Let's do 4 times 8 divided by 2. The other one was 4 times 4 divided by 2. Okay, and the other one was a 6 by 12, and then we're going to divide that by 2. Okay, so 4 times 8 divided by 2 is 32 over 2, which is going to give me 16, okay, units squared. Okay, and then 4 times 4 over 2 is 16 over 2, which is going to give me 8 units squared. All right. And then 6 times 12 is 72 divided by 2, so that's going to give me 36 units squared. Okay, so now to find the area of this trapezoid, what I want to do, so the area is going to be equal to, and we're going to take 150, okay, and then minus 16, minus 8, and then minus 36. Okay, so doing that, and this should be 120, I'm sorry. This should be 120, okay, and so now, all right, let's do 120 minus 16 minus 8 and then minus 36, and that's going to give me an entire value of 60, okay, and that's units squared. Okay, so remember, if you find the area of the big rectangle, then you can go through and you can subtract out each of these individual pieces, and the area that you're left with is the area of the trapezoid, and that's what we have here, okay? Okay, on this one, this question is asking us using the area formula to find unknown side lengths. So, I have the area of a trapezoid is 86.86 square inches. The height of this is 17.2 inches, and one of the bases is 6 inches. What is the length of the other base? So what I'm going to do is I'm going to draw a picture, okay? And I'm just going to draw a generic trapezoid, all right? And I know that my height, this length here, my h is equal to 17.2, okay? And I know that one of my bases has a length of 6 inches, okay? And I want to find the length of the other base. We'll call this b sub 2, all right? And I also know that my area is equal to 86.86 inches squared, okay? So if I think about, and let me label this as b sub 1 is equal to 6. Okay, so what I want to do is use my area formula, and I'm going to do this. And I'm going to say it's the height times b sub 1 plus b sub 2 all divided by 2 is equal to my area, okay? So because I have my area, I'm going to substitute 86.6 into my A value. I'm going to plug in 17.2 into my height value. I'm going to plug in 6 into my B sub 1 value, and I need to solve for B sub 2. So let's do that. So I'm going to do 86.86 is equal to 17.2, all divided by 2, and then this is times 6 plus b sub 2, okay? So what I'm trying to do is I'm trying to solve for b sub 2. And you can do this a number of ways. Now it just becomes an algebra problem. And so what I'm going to do is kind of look at this differently. I'm going to do this. I'm going to write 86.86 is equal to, and I'm going to do this. I'm going to take my 17.2, and I'm just going to go ahead and divide that by 2. Okay, I'm going to do this division right here. And that's actually going to give me 8.6. So when I do this division, 17.2 divided by 2, that's going to give me 8.6, okay? And then I'm going to multiply that by 6 plus b sub 2. Now what I could do a couple of other things here. I could go ahead, I could distribute my 8.6, or I could divide by that 8.6. I'll just go ahead and divide by 8.6 on both sides. Okay, so 8.6 divided by 8.6, that divides out. If I take 86.86 and divide it by 8.6, so 86.86 divided by 8.6, that's going to give me 10.1, okay? So this value is 10.1, and then that leaves me with 6 plus b sub 2. I'm going to go ahead and then just subtract 6 from both sides, and that's going to give me a value of 4.1 is equal to b sub 2. Okay, and that's how I do that. So, if you know what the formula is and you're given certain things and you're not given one of them, like we weren't given the second base, then you can just plug it into the formula and solve. This one's kind of tricky because there's just kind of a lot of different methods on how to do that, so that's something you may want to practice and look at. Okay, let's take a look at this one. It says the perimeter of the trapezoid in the coordinate plane. So let's go ahead and graph these points. I'm going to graph the point 4, 4, right here. Okay, I'm going to graph the point 11, 4, so right here. Okay, I'm going to plot the point 20, 10. Okay, so 20 and then 10 right here. And then the last one is 410. Okay, so I've got this length of 410. All right, so now we want to find the perimeter of this. All right, let me go ahead and just put these all together here. This one shouldn't be too bad. I'm going to call this point B. I'm going to call this point C. I'm going to call this point D and call this one point E. Okay, so what I want to do is I want to find the length of BC. Okay, I want to find the length of BE. Okay, and then I want to find the length of ED. Okay, and then I'm going to find the length of CD, and then we're going to add them all up. Okay, so if I find the length of BC, now we could use a distance formula, or we could just count, and we know that this point starts at 4 on the x-axis and ends at 11. So I know that this length here is 7. Okay, if I were to try to find the length of BE, so BC is 7. Okay, if I find the length of BE, okay, that's a vertical length. I go from 10 down to 4, so that's going to be a length of 6. Jim's back. Jim's here. I can hear him messing around over there. ED, okay, I go from 4 on the x-axis over to 20 on the x-axis, and so that's a length of 16, okay? So this is a length of 16, but now we need to figure out the length of CD. Now CD is a diagonal, okay, and so I'm going to do this. I'm going to draw a little right triangle here, connect those, okay, and the length from 11 to 20 is a length of 9, okay, and then the length from 10 to 4, this length here, is a length of 6. Okay, so if I wanted to find the length of CD, I'd use the Pythagorean theorem and say that that's going to be square root of 6 squared plus 9 squared. Okay, so the square root of, what is that going to give me? 36 plus 81. Okay, and then let's add those together, see what we get. So 36 plus 81 is going to give me 117. Okay, and 117, I believe, is a prime number. We're just going to go ahead and leave it like that this length CD is a length of the square root of 117. Okay, so this length here, all right, is the length of the square root of 117. Okay, so now if I wanted to find the perimeter P, okay, all I'm going to do is add these numbers up. So I'm going to take 7 plus 6 plus 16 plus the square root of 117. Okay, you can add all these up. 13 plus 16 is going to give me 29. Okay, so then I get that my perimeter is equal to 29 plus the square root of 117. Okay, and let's add that in there. So I've got 117 square root plus 29 is going to give me an approximate value. I'm going to round to the nearest tenth because that's what it's asking me to do, and I'm going to round to 39.8. Okay, and that's going to be units. Okay. We're just dealing with a regular unit. All right, so that's that. All right, so that one was kind of nice because those lengths were horizontal and vertical. And let's go ahead and look at the very, very last one. And it says the area of this rhombus in the coordinate plane. So what I'm going to first do is I'm going to label these points. Okay, and let's go ahead and label this point here as the point 4, 2. Okay, so 4, 2. All right, L is the point 12, 4. Okay, 12, comma 4. M is the point 14, 12. Okay, and then N is 6, 10. Okay, and so remember, if we're trying to find the area of the rhombus, we need to use the formula area is equal to d sub 1 times d sub 2 divided by 2. Okay, and d sub 1 and d sub 2, those are diagonals. Okay, so I'm going to do this. I'm just going to go ahead and draw in my diagonals here from NL. Okay, and I'm going to draw in the one for KM. Okay, so draw that one. Okay, so NL, I'll call that D sub 1, and what I'm going to do is I'm going to draw a right triangle to figure out what those lengths are. Okay, and this is a, what do we got? A length of 6 here. And then this is a length of 6, okay, from 6 to 12. Okay, and so I have that, so that's good. So let's write that down. Let's write that NL. All right, just trying to find that. And that's going to give me the square root of 6 squared plus 6 squared. So NL is going to be the square root of 36 plus 36, okay, which is going to be the square root of 72. Okay, now I can split that up, and I can just then go ahead and say that this is going to be the square root of 36 times the square root of 2. Okay, and then that's going to give me that NL is equal to 6 times the square root of 2. Okay, so that's that value. All right, let's find Km. Now Km's a little bit longer of some lengths, but let's just go ahead and just draw that right triangle. Okay, and the distance from 4 to 14 is a length of 10. The length from 12 down to 2, this vertical length, is also 10. Okay, now what I know is that, if these are isosceles right triangles, then I automatically know that my diagonal is going to be a length of 10 times the square root of 2, much like how this one became the length of 6 times the square root of 2. So I know that Km, okay, we could do Pythagorean theorem, and you could say that it's 10 squared plus square root of 10 squared plus 10 squared. Okay, or because you know that it's a 45, 45, 90 triangle, you know that hypotenuse is just going to be 10 times the square root of 2. Okay, and we can just go from there. All right, so, what I'm going to do, we'll call this value d sub 1. We'll call this d sub 2. So if I were to find my area of these, okay, I'm just going to plug them in up here. My area is going to be 6 times the square root of 2. Okay, 6 root 2 times 10 root 2. And we're going to divide all that by 2. Okay, so now let's simplify this. Now, we don't have to use a calculator here. The square root of 2 times the square root of 2, I can reorder all this. I'm going to do this. I'm going to do 6 times 10 times the square root of 2 times the square root of 2. Okay, reorder everything. Put my numbers next to each other. Put my radicals next to each other. Divide this all by 2. Okay, so then I've got that this is going to give me 60 times the square root of 4 all over 2. Okay, and all I did, 6 times 10 is 60. Square root of 2 times square root of 2 is square root of 4. Now the square root of 4, that's a value of 2. Okay, so I get 60 times 2 all over 2. Now the 2's divide out. Okay, and they leave us with 1. So then my area of this rhombus, is just 60 units squared. And that's it. Okay, so it's just one of those things. You just gotta use Pythagorean theorem, know what you're trying to do what you know, and plug your numbers in and evaluate. Okay, it's all right to use a calculator to check, but a lot of the stuff can be done by hand. So I hope you enjoyed this video. I know it was kind of a long one, but we'll see you soon. Thanks. Bye.